Hello and welcome back. My name is Corey, and for the evening, you're my rubber ducks. And this is the series where we are creating a programming language called Tang from scratch. And that is, we are C++ and just our raw programming skills. I'm doing it 100% live coding, nothing up my sleeves, no, I'm not copying and pasting anything. And we've got a big task for tonight. That is, we want our language to have functions. Now, this is a huge topic in and of itself, and there's a lot of parts that have to be written. I don't think it can all be done in one session. Well, I mean, I could. It would just I'm afraid it might be a 4-hour session. So I'm going to break this up a little bit. But our goal for today is to be able to declare a computed, declare a function and compile that. Don't know if we'll be able to execute it yet, but have some sort of representation. That's the goal. Okay. So as always, we'll just go right into the work here. If I say git log, you can see the last thing that we did was episode 35. It was the documentation stuff for that. And let's see, git status, nothing hidden. So we are starting from where we left off. And if we think about, in fact, I think I've got this here. I can pull up and bring over to show you. This is our GitHub page about Tang. And I have an example of something that I would like to be able to do. This just it computes the Fibonacci sequence in a very inefficient way. But that's kind of the point of this, or of me writing it this way, is that it is inefficient and we should be able to parse this type of code. So again, we could use DEF like Python does, or FUNC for function. I prefer to just use the word function. We have a name. I should probably make that larger so that you can see it easier. There we go. Name, fib, some arguments to pass in. There's a code block, and we've got a return statement, and it can be in more than one location. That's gonna be a little difficult. How do we do the returns? We'll think about that. Again, I don't know if we'll get to it in this case. And then we have to be able to call the function. So there's a lot of parts here. If we think about this as an AST for the abstract syntax tree, right? What kind of nodes do we need? Obviously, we need a node for the return statement. We need an AST for the function declaration, and we need an AST for the function being called. Okay. So those three. What about what kind of computed expressions do we need? Well, we need a computed expression that can represent this function. I'm trying to think if there's anything else that we need. I don't think so. Well, I guarantee there's more. The thing is and I'm going to take a break here or just a moment to point out, there's more than one type of function call. There are standalone functions. That's what this is, that we wrote in our language Tang, and it's being compiled to bytecode. So we may call that a compiled function. And then there may be functions later that are provided, that were written in C++, but that are provided to Tang by way of, it's a library. Okay, that could be, we could call that a native function. And then we will also later have objects that you might call a function on. So if you've got a string, you might say if the string A, so A is equal to hello world, you might be able to say A dot length, you know, semicolon. Not semicolon, but open close parentheses. And in that case, you're calling a function, but it's bound to some variable. And that's a bound function. And then the question is do we need bound native functions, that's the C++ ones, and bound computed, or the compiled ones? And I'm going to make the executive decision to say no. We do not plan on supporting the declaration of object types and everything like that, and inheritance and all that other stuff. We're not doing that in our language. At least we're not allowing the end user to do it. Why? Because this isn't PHP and it's not Python. And we're not trying to write that robust of a language. And what I mean by that, robust, I don't mean as in this will fail. Rather, I'm trying to say we're not trying to add that as a feature. This is supposed to be for small templated scripts, right? Small things. You shouldn't be defining, 100 lines of a class only to, have just something very small in the way of a script. So I'm going to say no. We're not going to have bound functions that are bound to compiled code. We will only have bound functions that are native in nature. So that's 3 different types of functions. And of course, we don't need those 3 now because we don't have the ability to have our native functions yet. And we definitely don't have our ability to have our computed expressions yet. But we have to write our current stuff that we do with this intent, knowing that we're going to need to support this type of information. Yeah. Okay. So where does this put us? We have to start somewhere. And I'll be honest, I've been putting this off. I've done other videos knowing that I wanted to get to functions, but also because of how much work I knew that it was, I've been kind of scared off from it. So we're just going to jump in. I think we're going to start off. I'm not going to do the, should I do the makefile? No, I'll do that in just a moment. First, I want to, no, we'll do the makefile. And what are we going to try to get done? First of all, we need bare minimum. We need our return AST node and our function declaration AST node. So let's do it. We'll put it right after the AST node 4. And we'll say function declaration. There we go. Function declaration, and then the other one is going to be the return. So it'll go right after the print. So we've got return and function declaration. Can we get these compiled today? I don't know. I've tried to get to a stopping point for each one of these where we can always have something compilable. This one we may not. what did I say? We're doing AST node function declaration. 76 and 77. We're going to substitute float for function declaration. Okay. And now, what was the other one? Return. And now, on 96 and 97, we're going to substitute print for return. We may not even get the return stuff done today. We'll think about it. Okay, we also will need a computed expression. So I'm going back up here. And what is our computed expression? It's going to be a compiled function. So a computed expression Boolean. I'll go after that. Compiled function. Oh no, that was AST node. Should have been computed expression Boolean. All right, 151 and 152, we're going to substitute Boolean for compiled function. Okay, we did it. So let's start making some stuff. We need to copy the include for the AST node, and for the return it has one argument. So let's copy the unary. Include AST node return.hpp and do the same thing for the source. AST node unary source AST node return. Sorry, I'm just all of a sudden double checking. Said, was I on autopilot? Okay, so for the include AST node function declaration has multiple parts, one of which is a code block. There's nothing really similar to it. Maybe a while. And then include AST node, and what did I say? This is a function declaration .hpp. AST node while include AST node not include source AST node declaration.cpp. All right, and the last one was the computed expression, and it's going to be, this is a, I'm just going to copy the integer. Include AST node, and this is going to be not AST node, computed expression. What did I say this was? A compiled function .hpp. Computed expression integer. Source computed expression compiled function.cpp. Okay. Now we need to start throwing this stuff together. I'm going to start someplace that I don't normally. Let's do Flex and Bison. Why? Because I think it'll at least help us get started. This is Flex. Let's do Bison first. And so we're going to have these token function, and what else? Percent token return but we'll get there. Pardon me while I consider something for just a moment. You know how we did these statements? I think we're going to need to do the same thing. However, for the function, think of it, a function declaration, you have to give variable names. And so we're going to need a what happens when I get an identifier? Yes, I know I stopped talking, but it's because I'm thinking. So that's a double quoted string. An identifier is just a string. Okay, that works. I am going to add a percent type of a standard vector of standard string, and we're going to call this function declaration. Arguments, function declaration arguments. I think we can deal with that. And this is, again, it's the idea of being able to say the function name, and this is declaring, right? Function, the function name, open parentheses, a comma b comma c. That's going to represent that information. Okay. We know that we're going to have some pound includes to add. What are our pound includes? Pound include AST node function declaration, and I know I can't type include. Pound include UDE. AST node return. Okay. And now let's populate some of these. So one of these, not an expression, but a closed statement. So a closed statement is where we put all of our kind of possible things here. One of them could be pipe return expression. Oh wait, I could have written that as return expression semicolon. That would work. And if I do that, then I do a that's equal to standard make shared AST node return. And what are we going to give it? We're going to give it the $2. That's the expression. And the location is 1. Okay? That's a statement. Another one. Okay, so these are the 4s. Let's put it here. Another one could be function identifier open parentheses. What did I call that? FUNC function declaration arguments. And then a close, and then code block. All right, so what would this be? This would be equal standard make shared an AST node function declaration. And what are we going to pass it? We're going to give it the identifier, the name, that's $2, the vector of function declaration arguments, sorry, brain stopped working. $4, and the code block, of course, that's going to be $6, and then the @1. Okay, so the only thing now that we're missing, I think, is this function declaration arguments. And we can going up here, just looking for where I want to put it. I kind of want to stick around the statements because it's kind of the same thing. Function DE declaration arguments is a comma separated list of variable names. Declaration. Okay. So what could this look like? Let's say the first one is empty. In that case, we should $ is equal to a standard vector of strings that has nothing in it. I think that will work. What if it is a single identifier? I hope this doesn't create a shift-reduce conflict. That is a string, and so we're going to say equals standard that has $1. And I'm probably just making a silly mistake here, but, or it could be recursive. Function CLA. Oh, wow. I couldn't spell. I see this up here. Declaration arguments. Okay. Copy and paste. Followed by a comma, followed by an identifier. So the $1 is it's a vector of string, so I can say $1 dot push back $3 and $1. There we go. So this may look weird, but realize that these are just patterns that are going to be replaced by Bison in actual code. It's using this file. Bison will use this file to generate code, and whatever function declaration arguments is, its type up there. We said it was a vector of strings. Well, it's a variable that its type is a vector of strings, so we can just say dot push back, and it'll say, oh, I'm a vector of strings, I'll push back whatever, and $3, well, that's identifier up here, and that's this identifier, and it'll push back just fine. And then the double $, that's what we return up. So how will this work now? If we have a function that is open parentheses, close parentheses. So it's a function that takes no arguments. It's going to use this empty, and that will create an empty vector of strings, and okay, so that's fine. If it's got 1, it's going to find this case identifier. If it's got identifier comma something else, the first identifier will hit I didn't mean to do that. There. The first identifier will hit this case, and it will return. That will be a function declaration arguments. And then when it finds the comma, it'll say, oh, well, this pattern That matches the function declaration of arguments. That's the first identifier. Then I found a comma and another identifier, and that will become now a big function declaration arguments, a vector of 2. And then if it has another comma after it, it'll do this again recursively until it runs out of arguments. At least that's the theory. I'm hoping it works that way. Okay, so I'm saving those. I think we've got everything. Now what do we need? We need to tell yeah, we need to tell Flex how to recognize these parts. So let's do that. What are we missing? What keywords? Well, first we've got, put it right down here, we've got the word function. Make function and location. There we go. Easy enough. What else? Oh, the keyword return. Return and with the location. Okay. Is that all? Did we already have commas? I don't think we had commas. I'm looking for commas and they're all... Yeah, we didn't have commas. Okay. We need to tell it to look for a comma. Do I have to escape at a comma? I don't know. We'll find out soon enough. Let's put it down here with all the other various and sundry things. There. And this will be a comma. We need to go back to Bison and tell it what a comma is. There we go. Okay, in theory, these two should work. In fact, no, it won't compile. Okay. But it will tell me what I've done wrong. Let's do this. Test just to get it over the hump. What did I say? 126, line 126. There we go. So I'm missing a closing. There we go. All right. This is actually good news. What we've got so far is we've got so Bison ran its thing. No shift reduce conflicts. That's good. What about Flex? Did we even get that far? It's giving me an error on trying to compile this because we haven't done our changes to our source code yet. So that's fine. It won't do any more. So I think we're going to have to fix that problem before we can go on. Yep, we're going to have to do that. Let's fix that problem. So say get status, it'll tell me what are the ones that I added. So let's vim include, let's do the node return first. Source AST node return. %s will replace unary with return, and we'll do the same thing for the title case, unary with return. Okay, now let's clean up. So an AST node that represents a return statement. We don't need this enum class. Constructor. Will it have an op? Nope. It will have an operand. We'll call that the expression. In fact, colon %s BERAND operand expression there. We'll do the same thing with %s operator. Should not be an operator, but it should be a oh, we don't need that at all. Sorry. All right, let's go back up here. The expression to be returned with the statement. Okay. Now, we don't need that. We just have an expression on location. We don't need that. Expression, dump, compile, collect identifiers, collect strings. All of those need to stay. Okay. Let's do the same substitutions. No return. Are there any others? Okay. Let's see. In our constructor, we don't need this operator up. We don't need it here either. Expression. For the dump, we don't need any of that. This is going to be return. Don't need the description. There we go. Return, new line, and then that's fine. Collect identifiers, expression, collect strings. Yep, that's good. Compile. Oh boy. Well, we compile the expression and then return. Is that what we should do? When we say return, I mean, can we just do that? Can we just say return and that's it? I think the answer is yes. I think it's a yes. No, my caps lock's on. There we go. Okay, so our AST node return is good. Let's do the function declaration. Our include AST node function declaration, and our source AST node function declaration. First, %s, we're going to substitute while for declaration. Okay, there. Make sure I got it all. Do the same thing with the title case. Why did I choose such a hard word? Hard word to type. Okay, let's see. That represents a function declaration. Simple enough. So a constructor. Do we have a... Nope. So at param, what's the first thing? It's going to be a name, and that is the name of the function. The next one is going to be arguments. The arguments supplied, no, the expected to be provided. That's good. And last but not least, code block. The code executed as part of the function. Sure. All right. So what all do we need? We no longer have this. We've got a standard string to a name, a standard vector of strings, and this is the arguments, and then code block. So just in case, include string pound include vector. There we go. We do need the dump, the compile, the collect identifiers, and collect strings. Yes. And we don't need the condition, but we do need the function, and that is going to be a standard string name, and then expected to be provided, and that is a standard vector of standard string arguments. And then there. Okay, so I think that's everything. Yeah, no, it says it doesn't know what return is, but we'll get there. Okay, now time to do some substitutions. Function declaration, okay. And now, what all do we need in the constructor? We had a string that was the name and a vector of string, that is the arguments, AST node location, arguments, there we go, nothing else. Yeah, that's right. Okay, so the dump is going to be a function declaration. The name, it's a string. The arguments, I know how I could do this in a few other programming languages, but there. For yeah, I'll do it that way. Yes. I wish there were a cleaner way of doing that, but shouldn't have done it that way. Well, indent plus temp, and then the code block. Okay, so I've got the name, the arguments, and the code block. Arguments are separated by a space. The compile. Let's come back to that. The collect identifiers. This isn't quite right. Basically, because of the way scoping should work, we don't want to sorry, brain stopped, but I know what I'm thinking. We don't want to I was going to say violate the scope. If there is a variable inside of a function called a, we don't want that to affect any variable on the outside of the function. So we don't want to pass through this collect identifiers. In fact, the only thing we want to do is, and we may need to open up the collect identifiers for what's something that's an identifier. The AST node, this would be source, AST node, is it identifier? And the only reason I do that is because we only want to reserve the name. And is that even right? we'll leave it for now. The thing I'm thinking about is, what if you declare function, foo, and then in another function you want to call that. You would need to. We'll cross that bridge. I know what I'm trying to say is. I'll just write it out here. If you have function foo a, function foo b, and inside of this you want to call foo a, we're going to have to also declare that that's a function that foo b needs to be able to know about. So that even though our function name is like a variable name, it's also special. So, okay, we'll burn that bridge when we get to it. No, we'll get there. But for right now, just the identifier name. Okay, what about the strings? Do we have to collect any strings? No, we don't. Because that is going to be as part of our compile. Okay, so this is where it's starting to get messy. I can take out the collect strings, and it's still not going to like yeah, so it doesn't like any of the compile, and that's okay, I don't like it either at this point. So what do we do here? Well, as always, it's good to start out by kind of blocking this out. What should a compile do? I mean, think about it as in quite literally. So there needs to be, I need to know, first of all, auto jump past function is equal to program.get bytecode dot size. Now what it is I'm about to do that, but okay, so this is jump past the program, not the program, the function bytecode. Okay. That we are about to compile. All right, now what? I know I'm adding a lot of lines. It's just for my own sake. Okay. Now that we do that, we're going to compile the program. Okay, but what would that look like? That would look like this arrow code block arrow compile program. Okay, now what should happen? It's a code block, and there should be one value left on the stack. I'm going to make the decision that if there is something on the stack and there's not been a return, then we will use that value that's on the stack as the return value. Okay, so compile the program, and there is now one thing on the stack. So when it is should Yeah. I know. You're saying, Corey, finish up. I want to check. Did I do in one of my old ones? I just want to check my opcodes that I used. If I can do it quickly, that is. Said I was going to try to do it quickly. Sorry, this has a completely different You know what? This is not done. I'm going to have to think about this more. You say, Corey, I thought you're... Well, I know. So, at this point now, we have a target for that jump past function. And we can do that as... where do we set it? There we go, set jump target. Of the jump past function, and it's going to be our current, or the next instruction. And what's the next instruction then going to be? Well, we need to now push a computed expression. And what did I call that? Compiled function onto the stack. And what do I need to know for that? That's going to be program.add bytecode uinteger underscore t opcode that doesn't exist yet. And we're going to say that this is a function. Just like we had integer or whatever. Okay. But what information does it need to know? It needs to know is that right? I did this completely differently before, so I don't have good notes for this. Okay, I think we're going to need to add. Okay, what's in our computed expression? Did we do that yet? Include computed expression compiled function. Oh no, I haven't done it yet. That's why I'm like, what did I do there? Haven't done anything. Okay, so what does our compiled function need? We need a we need to know where it starts. So there we go. Auto function start is equal to program get bytecode size. Okay, function start. So this is where it starts. I'm sorry. I'm thinking ahead. And the thing is when the function gets compiled, oh, I think I can check that though. That's the computed expression. Okay, I'm in the wrong place. Oh, yeah. Okay. So, I think so before we compile the program, and yes, I know I'm kind of going out of order, but we need this whole sort of This is where it's getting messy. I know. I'm not doing a good job at explaining it, but it's because it's complex. We need, when we call the function, it should set up everything correctly, right? So it should reserve all the space that it needs. Well, okay, wait, let's think about how a function would be called. Let's say it has 3 arguments. It would push onto the stack, or the person calling it would push those 3 arguments in the correct order, right? If it's a function A and it requires an A and a B and a C, whoever's calling it will push that A and then B and then C. But the function itself then has to set up stack space. So what if it has additional what if it has additional variables that need to be reserved? But there's some overlap, right? So what if it requires an A, B, and C, but then it also needs an X and a Y and a Z? Then you don't want to double allocate those stack positions, but you do want to get the A, B, and C. I mean the X, Y, and Z reserved. Maybe we won't worry about that yet. But I do think we're going to need to do this. We're going to need to say prepare a new function environment, and that's going to be a to-do. Okay, and then reserve stack positions for any variable in the body that is not in the arguments. To do. Okay, and then we would then we could compile the function. Okay, after we do that, we would need to restore environment because we have finished with the function. So the op return I was slightly wrong. You see, the function's got to clean up after itself. That's kind of the point. So what needs to happen when you say return 3, it needs to, or return whatever, the return needs to pop that off the top of the stack, clean up the stack, including the arguments that were passed to it, and then put the 3 back on the stack, so it's the only thing left. Yeah. So I don't need to, I only need to give it the function start. Okay. And now copy yeah. Compiled function. I need to copy that into the variable name that was reserved for it. Okay. And that's going to be program.add bytecode and that's going to be our poke, and program.add bytecode, and that is where do I store this? Is this the identifier? The compile? I don't think I have this here. So what I'm looking at is I want if I should probably put this here. Identifier dot count this name. It should be there. Then identifier, this name. Restore the environment. That's a to-do as well. We don't have that. How to restore it. Now that we're at the end of sorry, brain stopped working. Okay. All of this is right, except for this whole stuff about the function environment and the whole how do we get the stack. Okay. If we edit... Okay, we're going to have to edit the include for the program.hpp, the source for program.cpp. We'll go with that for now. Okay. So our program, we're going to need a function that got set jump target. What do I want to call this? I think begin a new environment. And what an environment is, it could be used in several different ways, but in terms of language design, the environment is usually everything that is applicable to the execution context. So in this case, when you can think of normal, we've got a script and say there's variables A, B, and C in there. But when we go into the function, it has its own scope. And so it would have different variables. And you say, well, why aren't we just calling it scope? Well, because there's a few other things, not just the variables that are included in that. And conceptually, as we're doing the programming, we're thinking about it as, okay, I'm in a new environment. There's everything could be different. So we need functions to do this. So begin a new... begin anew. That sounds very hopeful. Create a new. And I think this will be a void and just push environment. And this will be yeah, I think I like referring to them as stack entries. So void pop environment. Okay, and so what is this going to look like? We've actually kind of done this a little bit, and we're going to do this here. We're going to say void program push environment, and we'll come back to you. Void program pop environment. All right, now these, the identifier stack, the string stack. Oh, and that's, we're gonna need to pass in a shared pointer of an AST node. And that's going to be AST. Sure, why not? Okay. Let's add that. Am I spelling environment wrong? Nope. At least I think it's right. Just all of a sudden doesn't look right. And this is going to be a standard shared pointer to an AST node. All right. We have already done this a little bit. And that is going to be nope, we're fine. I thought I'd made a mistake. I was mistaken. Hopefully it doesn't complain about shadowing. I don't think it should. Reserve spaces on the stack, compile the program, blah, blah, blah. Okay, for the pop environment, Okay, I'm liking this solution. And what would normally happen is after you compile the program, then you would release it so that it doesn't take up space, right? So it would be that's the goal. Okay. So pushing an environment, popping an environment, it's on the program, and yeah. All right. So now let's go back to not that. Prepare for a new function environment. It's program dot environment, push environment, and what are we pushing it for? What's it called? What are we about to compile? Oh, code block. So this should prepare the environment for the code block. Now, what if the function is declared with A, B, and C, but inside it they don't use A and B? They only use C. They're going to push in A, B, and C, but we need to make sure that we've... Yeah. Okay. I know I just kind of stopped talking. So... Okay. I know what I'm just double checking. I need a function Is it going to be used by more than one? You see, okay, so what's the problem? Well, we've got our I can just go to it. There, in our push environment, we've got our identifier, which is a map of strings, right? These are the identifiers, A, B, and C. And now, then we've got our strings, and that may have stuff in it, may not. We're going to collect our identifiers, and that is going to populate these map entries with size something, right? I mean, A is going to have a 1, B is going to have a 2. But the problem is the order that they're declared in the function, like foo, A, comma, B, comma, C, A needs to be the first one. So I need a helper function It's so specialized, though. So I'm adding a few other things. So add a to the environment. And that will be sorry, I wasn't being very hygienic as I dealt with this stuff, was I? And I think I want to protect this variable thing, and you have to call the add variables, and I haven't done that on others, but let's see, get the variable of the current environment, and that is going to be a, what does it return? A map of to current environment. And this is going to be, it's going to return a const map of string to, what is this? Oh, it's identifiers. So it shouldn't be variable, it should be in identifiers. But anyway, okay. The current environment. It returns a map of the of each identifier name to the current environment. Okay. And I just looked at that. What is its type? size underscore t. Fine. Get identifiers. It's a const. Okay, so instead of add variable, add identifier to the environment. What I'm thinking is I'd like to specify the stack position, where to add it. But do I start at stack position 1 or stack position 0? Push environment, pop environment, add variable. You know what? I haven't done this in a while. Let's just use an optional. If provided. Okay, add an environment. So we've got add variable, we've got get identifiers, and I think we're going to do the same thing with the get strings. We're just locking this down, aren't we? String map of the current environment. Okay. String to a size t. Get strings. Okay, and now there we go. There. Okay, now a lot of stuff is not going to be happy. So what do we need? We need to do the get strings, get identifiers, add variable. Okay. just copying these because save myself a little bit of typing. Don't know why I copied all that stuff. Oops. All right. So get identifiers is just going to be return this, what is it called? Identifier stack. You know what? We should check. No, it won't let me do that. I know it won't, because that's putting something on a stack and that's wanting to do a reference, so it won't let me do that. You know what? We're just going to say if you call it wrong, it's going to crash. Just don't do that. All right. Remove some standard stuff here just because it's messy. Get identifiers, get strings, add a variable. Where's that add variable? Because that's going to need to be standard optional. What does this look like? See, it's why am I protecting these? Well, I mean, I know why. I know mentally. I just haven't expressed it. Basically, what we need to do, if we've got to be efficient about this, when we add a variable, right now we've just been saying kind of add it to the back. But, and in fact, I can show that to you. Do I have the identifiers open? So we're coming back to I guess 5, but we're going to 3. Okay. Right now, collect identifiers, we say, in fact here, now, that's what we're currently doing, except instead of program, it's going to be this arrow. Okay, that would give us the exact same thing. And in fact, we should do this now. That's simplified. And the string that's in the source AST lowercase AST node string is similar. Where is it? Compile, not the compile, collect. Oh no, wait, but I don't have an, I need an add string. Crap. So add variable. No, that should be add identifier, get identifiers. I should have an add string. Okay, and it should be this, and it should be val. Okay, so program add string. This should be add identifier. And now let's do this. Identifier. Add a string to the environment. Add string, and I don't need the position. Okay. So now I've got these. Okay, add identifier, get identifier, add string, get strings, get strings. That makes more sense. Oh, it is get strings, add string, add identifier, get identifiers. We're good. Now, by default, add string is going to just add it to the strings thing. Not add string, add identifier. If a specific position was requested, then swap. As necessary. Okay. So what we want to do, say if position. All right, now if position is given, then what is a good way of going about this? Well, we could say have a map of size t to string flipped, and I mean that's flipped, for auto I of identifiers. So we're going to go through all the current identifiers, and identifiers is a string to the number, but we want the opposite way. So we just say flipped sub I dot second is equal to I dot first. Okay, so now we've got that. Well, first of all, before we do this, we should say if there's a position, and identifiers sub name does not equal position, because it's an optional, so we dereference it, quote dereference it, and that gives us the actual value. I don't have to put it in parentheses, but I want to, just for my own mental sake. And by the way, this, it shouldn't be this name, it should just be name, same way here, name. This should be outside of that. Okay. Swap entries. Okay. Flipped. Flipped is populated. Now, what I need to do is I need to flip the values. Identifiers of I don't need a temp because I've got, I mean, that was provided with the name that was passed in. So, the name of flipped of position. So whatever's at that position, its identifier is going to be say, Corey, this is messy. I know. Is going to be whatever identifier sub name is. And now identifier sub name is going to be position. Is that right? So whatever was, that's the flipped. Whatever name was at the position is now going to be at whatever the current identifier name is. That's what this is. And then identifier subname is going to equal the new position. And we should probably say star position is less than identifiers dot size, and just to keep everything in bounds. Okay, I probably have syntax errors everywhere. But that's the add identifier. I don't have to do anything with add string. We're not worried about the order of those. Get identifiers, get strings. Now let's go back to what we were doing. And we were trying to compile the AST node function declaration. Is that right? Yes. All right. So reserve stack positions for any variable in the body that is not in the arguments. So I think that it's better to say auto, what is it called? Identifiers, auto ampersand identifiers. Well, is equal to, would it be an ampersand? It may give me an error. Oh well, I'll leave it. Is equal to program.get identifiers. Okay. And now what I need to do is I need to say for auto ampersand name in this arguments? Yes, that's what it's called. Problem is I need the position as well. Oh, why can't we get both of these? Okay. Size ci is equal to 0. I is less than size plus I. Fine, I'll do it the ugly way. Yeah, so I go through each one of mine and say I want A at position 0, B at position 1, C at position 2. Okay, and then, so I'm currently in 2. Let's look at 5. What's it going to do when I say, that's the program. There. I give it a position, and it's going to say, does it already exist? If not, add it to it. And now, if I give it a size, it's going to flip it, create this little flipped thing, and switch everything around. Okay. So now all the identifiers are there. So when I compile the program, but the only other thing is now okay. So let's go back to B5. When I'm compiling the program here, reserve space on the stack for each variable. I'm just doing a, you know, whatever. I'm going through there. This can be get strings. I don't think I want to change that one yet. I'll think about it. All right. But I go through and just make a list. But for this one, Do I need this? Yes, I do. But I need it down here. All right. So actually, so my comments aren't matching what I'm trying to do. This first comment should be ensure that arguments are listed as identifiers in the order that they appear in the function declaration. All right, and now that is that there. Now, reserve stack positions for any variables in the body that are not I is equal to this arguments dot size should that be a -1? I is less than program get identifiers dot size plus I, and we'll carry that. First, let's make sure. So if I have one argument, if I have 0 arguments, then I want size to be 0. And it'll then create, if I've got 1, then, oh. Wait, no, wait. We added it to the identifier, so they will all be there. Okay, yep, this is correct. And now that's correct. All right, now the restore is just as simple as program pop environment. Okay, let me think through this one last time. So we're going to, we know that we're going to have to, as it's compiled, or as the program is executing the bytecode, right? The function declaration is right there. So the very first thing is, hey, just jump past all of that. We don't know where to jump past to yet, so it's an unconditional jump for this, bytecode 0. Excuse me, bytecode 0 is a placeholder, and we're saving it as jump past function, and we populate jump past function down here. Okay, that's fine. Then we say, hey, we're about to do a new environment, starting from our code block. So figure out all of the strings and all of the everything that we need for that. We didn't do the strings. We reserved stack positions for the variables, but reserve spaces on the stack for each string. Okay. This looks like a flip. What am I doing here? So string literals is string size back dot size. Oh, yeah, it is flipping. And it's just saying basically the vector position of 0 is some string. And now I'm going through the flipped to actually, it's just a way of putting them in order. Okay. We must be careful to add them in the expected order. So compute forget the fancy words. So figure out the order first and put that into string literals. Okay, that's fine. Now that the strings are in the correct order, push them onto the stack. Okay. And I'm copying that here. Those comments. Because I had to figure it out once, I don't want to have to figure it out a second time. Okay, B2. You say, why don't, if we're just copying and pasting code, why do we have to do that? Because actually, it's program.get strings. And so instead of that, we'll just say strings.size strings. There, we use it twice there. Okay, so want to go through the flow again. We're going to jump past it. We push a new environment, and that will set up the stacks, and we'll go through and find all the string literals and the variables. Simple enough. Ensure that the arguments are listed as identifiers in the order that they appear in the function. Okay. That's fine. Starting with 0. That's fine. Reserve the stack positions for any variable in the body that is not in the arguments. So we start at the argument size, and for anything that's remaining, just add a null value. Okay. Put the string literals on the stack. Okay. Now, by the way, this will give us what we need. The program.get identifiers on the, we just did it, the source AST node return. Because the add byte, there we go. And this is program.get identifiers.size. That's how many, plus get strings dot size. Again, I haven't done this on other times that I've written it. So basically, return, think of it from the perspective of the code when it's executing. When it comes to return, there's going to be certain things that happen, but it needs to know how much of the stack it needs to clean up. So what all does it need to clean up? All the identifiers and the all the strings that are on the stack. Yes. Go back. All right. We push we push the string literals in the correct order onto the stack. That's good. Now we compile our program. That's fine. Now, things like the identifier, node identifier.cpp, it's not going to be able to get to the identifier. Rather, it needs to call program.get identifiers and I did that wrong. I should have done it here. Program.get identifiers. Okay. And the same thing with the AST node string.cpp. That's B6. In its compile, yeah, this should be get strings, and then everything else should be just fine. Go back here. Okay. At the end, if we've gotten to this point, that the function is cleaned up. By calling return. I just wrote this. All right, so return and what do we need to clean up? Identifiers plus strings. Pop environment, and this is a compile environment really, but that's fine. Set the jump target now that we are at the end of the function bytecode. That's right. Jump past the function to whatever the next location, whatever the next thing is. Add a opcode function, which is the start, and opcode poke, and it puts it wherever this name is. Get identifiers. Okay. That seems like it's correct. Now I guarantee I've got compile errors everywhere and blah blah blah, but it's going to complain that I don't have the opcodes. That is include opcode, and which ones do I have? I have function and return. Those here. Well, no, because function is a type. I want to put it with the function. Get PC number, program counter, the bytecode offset, and then push function at PC number. Seems easy enough. And then I'll put the return at the bottom, because to me that's returned. And we're going to pop stack no, it's not a pop, it's get, because that's the next thing. Get stack number, pop return val, pop stack number times push val, and then what? Restore function. Would it be the frame pointer? Frame pointer and restore program counter. Say, Corey, wait, what is that? We haven't talked about that. I know. That's on the execution of a function. We have to know where to go back to. And normally, in programming, that's put on the stack before, well, the order is dependent on couple different things, but it could go before. But you basically on the stack you would put all these information, but we don't really have. Well, we could do it on this one. No, we'll do it the way I was originally thinking. That's fine. So, what I'm wondering is at this point, what's not going to compile? Of course not. It should be get identifiers. And this is in the AST node assign. Okay. In the source AST node assign. It's because I hid this, right? Identifiers should have been plural. I'd intended for it to be plural. Oh, I intended for it to be a function call too. Node assign line 44. What does it not like? Okay. So the problem is I'm needing a browser. For the vector here, or the map, if it does not have this value, it will insert one, and therefore it's not constant, but identifier is a constant because I don't want anything messing with it. So C++ map, and there we go. Just need a reference document of some sort, and I had to use @ and it will throw an exception if it's not there, but I know it will be there. So .at, and that should compile now. We're probably gonna have to do the same thing in a few other places. Function declaration. Line 48. There we go. Oh, well, of course. It should be do this. It should be program.add bytecode. Copy and pasting, I tell you. And then '61. Okay, it doesn't know what AST node string is. Compile literal, and I need to pass it program. There we go. And 71. This. Oh, yeah. Get identifiers dot size and get strings dot size. And this is going to have the same problem. It's got to be '74. Don't know why I'm convinced that program is a pointer. Same thing. This is a, just making the same mental mistake. Oh, there should be get identifiers. Okay, gotta completely do this differently. It should be program.add identifier this arrow name. Yeah. AST node identifier. I already have that open. And what is this? AST node return. Oh, It's like this was a copy paste there too, or I made it in one and copy and pasted it to the other. AST node string. $25. Wait, what's it not like about this? Oh, I'm looking in the wrong file. Buffer 6. Get identifiers. Dot size. Okay, and there's another one. Yeah, key error. $53. Get strings. This, I think it should be program.add string this val. If that compiles, will be good. Oh, still line 25. I missed something. Again, you can't use the bracket notation since it's a const. Okay, so it's saying that this push and pop are not push environment. Oh, because this should have been a const shared pointer ampersand. Doesn't like the pop environment. Because that should be that. Don't know how I did that. Probably just fat fingered something. The good news is we're almost to a... Thought we were. Okay, so what does it not like? Oh, because I haven't done the computed expression part of it yet. Computed expression, compiled function, source, computed expression, compiled function. Okay. %s integer needs to become compiled function globally. %s what did I just do? No, I did it right. Title case integer needs to become compiled function globally. Okay. Represents a compiled function declared in the script. Okay. PC. The bytecode address of the start of the function. And now it's going to be, nope, that was fine. PC. Okay. I'll leave the dump. Make copy. No is equals. We'll leave the equal. But I can't cast it to anything. It wouldn't make sense. I don't need the computed expression float. And okay. I'm going to globally change val to PC. And now the constructor is fine. The dump is going to be compiled function. Okay. Make a copy. Compiled function of this PC. Sure, why not? The is equal. Nothing there. Negative not less than. Okay, if it's equal. If the right-hand side is a computed expression compiled function, that is exactly right. There we go. Don't know how to compare these values instead of PCUs. Okay, integer float, none of that makes any sense in this context. Okay. Now, in my defense, I told you that this is huge, and I've been sitting here for almost 3 hours now, just getting the compile set up. I haven't even done the opcodes other than adding them so it will compile. So yeah, this is next time. First of all, should be a lot shorter, and that'll be good because we did the brunt of the work today. But what do we need to do? We need to be able to execute the return, execute the creating of the function, and that should be easy to do. The return is pretty easy since I've already figured out how it works. It's going to pop off the value, pop off the number of items on the stack that are either identifiers or strings, and then put that value back on the stack as the return value, and then go back to wherever it needs to go, where it needs to return to. And so that's the whole PC. So restore the frame pointer and the PC. So when you call a function, which we haven't written that yet, but that's what's going to happen next time, we're going to call a function, and it's going to have to push on the values onto the stack that it's supposed to have in the right order, the A, B, and C. And it's going to have to store a copy of the frame pointer somewhere so that it knows how to restore it later, and also the program counter where it should go next. And that's how regular computing works as well. That's how we get recursiveness. And if that works, I mean, if we've got that done, then we should have functions working. And I really think that should only take about an hour total. And that's with writing tests. However, as of this moment, let's just... Nope. Okay. What? Because I'm going to do a commit. I'm not going to refresh the documentation yet, but I will do a commit because we're at a steady state where it compiles. So get diff, let's see, standard makefile. Makes sense. We haven't tried declaring a function yet, but that'll be part of next times. We added a bunch of stuff to program and made things private, which I think is safer. That is all right. So just making sure I got everything. Initial commit for adding functions. They don't work yet, but everything else still does. Okay. And I always have to say, so git tag -a episode. What episode? I don't know. I started this recording like 3 hours ago. Episode 36. Whew. And what a monster it is. Episode 36.036. The message is going to be the same because I am not very imaginative. All right. Now, let me just say this. You can see why I was putting this off. And yet, the point is, it's doable. It's just you start taking small steps and you figure it out. And yeah, this is completely different from how I've written functions in the past and the parsing. And you see I refactored a few things in program because, in my opinion, now it's safer and it deduplicated some code. And I like the fact that the optional value worked. Yeah, I'm happy with where I've ended up tonight, and I'm just sorry. I know it was a long recording. It may be that no one on the earth ever watches this entire video. I'm okay with that. At least I made the effort to put it out there. Anyway. All right. Thank you. Have a great day.